Okay, you guys need to give me, get involved here. Tell me anything you know about matter, some terms associated with matter. Instead of just looking down and reading out of it, what are some things you know about matter? Garrett, is there any term associated with matter that you know, that you've learned? Yep, it's all around us, yeah. Okay, yes?
Has mass.
Okay, has mass, it can weigh out. Okay, there's a quantity there. Okay, Martin? What do you think? Is there any terms related to matter?
Dark matter.
Yeah, there's dark matter, and we won't want to get into that complicated, but is there anything else? You don't know anything about matter that you guys have talked about in the past? Okay. Sydney, anything about matter? Any term? What's that? Okay. Jordan? What's that? Oh, that's all you know. Okay. Dylan? Yeah. So it has mass, it takes up space. What are some basic building blocks of all matter? Okay, so we had atoms. All right? Can you tell me a little bit more about atoms than just atoms? Do we know any specific about types of atoms? Okay, they're made up of other smaller particles, which we'll get to later, and we have elements. So what do we know about the elements? Where are they located? Okay, David, what do we call that? Periodic table. About how many are there on the periodic table? Okay, once you get to 92, those clear ones, they are made in the lab, which means they don't naturally occur. We can't find them. Okay, they're man-made. So once we get up to 92, then we're done. So there's around 90, a little over 90 elements. Okay, and that's it. Different types of atoms. Okay? So we know that there's around 30 billion different compounds. So those are the basic building blocks of all matter. What do they tend to do to make all those different compounds? They combine. Okay? And when they combine, they bond together, and what are those substances called where we have two or more different atoms hooked together? Okay. Compound. So we got compounds that form. Alright? So what we're going to do is we're going to get into some of these definitions, have you write some examples down so that you have them in front of you and you can study them if you need to. Now some of you kind of have an idea, maybe a little bit more about matter and what it is, and some maybe not as good an idea. Okay? So, when we fill this out, we're going to look at particulates. And you don't have to write this down right now, but I'm just going to go ahead and put what's called a particulate. Okay? A particulate is the smallest part of a substance that we can look at. So, what is the smallest particle of a substance that we can break everything down into? Joe, I think you said it. Right? Okay? But, and have the same physical and chemical properties. So once we get to protons, neutrons, electrons, then we're really breaking it down a lot farther than we need to. But we can do that. But what's the very smallest particle? What's the very smallest particle of all matter? An atom, right? So an atom can be a particulate. Again, don't write the definition down yet. Okay? Another smallest particle of all matter is when atoms hook together. And when they hook together, they make these things called molecules. And we're going to be drawing some of these here in the future. Okay? So we got atoms and we got molecules that we'll look at. And we can do drawings of those to represent those particulates and what they are. Okay? So we have atom. That's kind of our basic building block of all matter. That's kind of where we want to start. Okay? Martin, can you write that down, please? Okay, so we got basic building block of all matter. Write down 2 examples. Okay, you go ahead and write down 2 examples. Jacob, what did you have down for one example of an atom? What's that? There are atoms in there, but if we want to be real precise and know exactly what type of atom, then we'll probably want to use the periodic table and look off of there. Okay? But you're right, the desk is made out of atoms. Everything's made out of atoms. Okay? Alright, so Alexis, did you have something written down for an atom example?
Hydrogen.
Yep, hydrogen. You could write the symbol down, hydrogen. So you could write any of those down up there. So write down 2 examples, and we have symbols for elements, and they're an easy way to write them down. Okay, any questions that you have on that? So atoms make up these things called compounds. But before we get to compounds, we're going to do a molecule and know exactly what a molecule is. Because a molecule is a compound, or can be, and it also sometimes it's not considered a compound. All right? Depending upon the definition. All right? So the next thing we're going to look at is molecule. Before we do definition of this, let's do an example. Does anybody know of a certain molecule that you know of already that you maybe studied in biology or some other classes, science classes? That would be a combination of atoms. Yes. Okay, water. Does anybody know the formula for water? I hope you do. So you can put an example down, H2O. So we got a combination of atoms. Okay? And they exist as 2 parts hydrogen, 1 part oxygen. And so we have these model kits that we work with, and you will work with, that represent different molecules. Okay? So if there's water vapor in the air, high humidity or humidity in the air, these are floating around. Okay, well, this is just a model of it. So it's not for sure, this is just so we can see that the ratio for water is always going to be 2 hydrogens, 1 oxygen. Okay, always going to be that case. Right? So that would be how we could kind of model that and show that. Right? Do we have another example of a molecule? Glucose. Glucose is a molecule. It is C6H12O6. And that one's a little harder to put together. I'm not going to be able to put that together, but it does have carbons in it. These black ones would be carbons, and there's 6 of them. And there's 12 hydrogens and 6 oxygens, and it makes up the basic sugar in our body. So those are two good examples, okay, of what we're dealing with. All right? So a molecule is a collection of atoms. So they're collecting together and bonding together. So we've got more. Now it could be the same atom too, because this is a molecule as well. You guys know what that is? Oxygen. So when we breathe in, we don't breathe in atom oxygen, we breathe in a molecule of oxygen. This is also in the air that we breathe in, but we never use it. Nitrogen gas, it's 80% of the air. We don't even use 80% of the air. We use about 20% of the air. This here doesn't really fall apart or break apart. That is a molecule. So it doesn't have to be different elements hooked together. It can be, but it doesn't have to be. So it's a collection of atoms that move together as a single particle. So when we draw particulates, when we draw H2O, it might look like this. You don't have to do this drawing. You guys will be doing this. It could look like this. Okay? And this would be hydrogen, and that would be oxygen. So that's a particulate. We know that hydrogen gas kind of hooks together, kind of like oxygen gas, and that would be H2. You guys remember the balloon? We did that, right? The explosion?
Yeah.
We combined H2 and O2 and it exploded. But this was the particulate that was in that balloon, as well as oxygen was in that balloon. So it acts as a single particle. Now, it's kind of different. There's ionic compounds that don't exist as single particles. They kind of all group together, and we have a certain ratio associated with that. Okay? So we've got, on your list, we've got atom, and we've got molecule. Let's speed things up a little bit. We have this thing called element. We talked about it. All right? It's the fundamental substance. So it's a fundamental substance. There's 90 of them. Okay? There's 90 fundamental substances. And then those fundamental substances get together and they make water, glucose, nitrogen, oxygen, those type of things. And it gives us over 90 billion, or no, over 30 billion different substances. Okay? So we've got this thing called a compound. So how's molecules, compounds work? Well, compound can be something that doesn't exist as a fundamental unit by itself. When I talk about a fundamental unit, the example I have would be like an automobile. An automobile can move. When you guys drive out today after school, that's a fundamental unit, and we've got a lot of fundamental units out there, right? A lot of cars and trucks, okay? The things that make them up, like the wheel and the body and all the different things that make it up, would be like the atoms, okay? Or the elements. And so, when we take a look at compound, it not necessarily has to be that way, okay? So compound is going to include molecules, some molecules, not all, okay? Because a compound has to be two different substances, or two different atoms. Okay? So a substance composed of two or more different atoms bonded chemically. So let's look at our list. So we have atoms, smallest building block of all matter. We got a molecule made up of 2 or more atoms that can act like a single particle. Okay. We've got compound, a substance composed of 2 or more different atoms bonded chemically. We've got an element. It's a fundamental substance from which all other substances are made. Okay. Did we give some examples of elements? Elements would be the same as atoms. You could just write down any of those symbols and that would be the same thing. Okay? Compound. Let's give you some different compounds that are not considered molecules. Okay? NaCl is not going to be a molecule. We're not going to have a molecule of NaCl. Okay? You guys know what Epsom salt is? Okay? It's used for like sores and aches and pains it can be. That is not a molecule. It's MgSO4. That would be Epsom salt. Okay? The compounds we could also have included in there. Substances like water could be there. Glucose could be there. Carbon dioxide, CO2. But we would not have this in there, so don't write this down. O2 is not considered a compound. Okay? Because it's not 2 different atoms hooked together. They have to be 2 different symbols hooked together. Right? Hydrogen gas cannot be a compound. Because it has to be 2 different substances hooked together. Okay. We have this thing called substance. Pure substance. There's 2 examples of a pure substance. Okay? So when we talk about a substance, it's either going to be an element or it's going to be a compound. Okay? So substance is matter with a uniform and definite composition. So that would include, you can put off the side the examples, element and compound. So when I say a definite composition, you don't have to write this down. Water's always 2 parts hydrogen, 1 part oxygen. Carbon dioxide is always 1 part carbon, 2 oxygens. Okay? Copper is all copper atoms. They're all the same atom. Okay? Hydrogen gas, all, when it's diatomic, there's always 2 hydrogens hooked together. Okay? So those are all substances that are elements and compounds. Alright? And then we've got two more terms there, right? To finish up. We have chemical symbol. Okay? And we have chemical formula. Thank you. So chemical formula. We've already used the chemical symbol. Okay? It's shorthand for the element's name. The other chemistry class tomorrow, they have to write the symbol if given the name, or write the name if given the symbol for elements 1 through 38, 46 through 56, and 78 through 88, and 92. So they got about 60 they have to do. And the reason they have to do that is, and you guys will have to do some of that, is so you don't have to look at the periodic table all the time when you want to do a problem, because we'll be using a lot of these elements. Okay? Alright, and the chemical formula contains element symbols with subscript numbers. Representing ratios. H2O, CO2, carbon monoxide CO, glucose C6H12O6. So it tells you their ratios and how they're bonded together. Sodium chloride's NaCl. And so when we get into chemical formulas and naming those and that, they'll have certain ratios with subscripts that we're going to deal with. Okay, any questions? That took a little bit longer than I wanted to, but those are really important for us to differentiate between those. Chemical symbol examples, anything on the periodic table, you want to write down symbol-wise. So a lot of these are repeats because we're talking about similar ideas. Chemical formula would be anything with a ratio, like CH4, methane gas, CH4, CO2, H2O. Those are all glucose. You can rewrite those out if you want to. Okay? Alright, before you go, we're going to do this together, and then I'm going to have you do this as homework. Okay? You guys like to draw? This will be good. If you don't, well, you can do it. It's not real complicated. When we talk about particulates, we're going to be talking about mostly molecules and atoms or elements. Okay? So we're going to practice a couple of these and then you can finish the rest up. I don't think you need your books. This will give you enough information.
Do we need this sheet?
Nope, that is your notes, so just put that away. Okay, we're going to go ahead and turn the page over. They show you a molecule of nitrogen at the top. Okay, so they're saying they're going to come up with a symbol for nitrogen that looks like that. And when you put two nitrogens together, that's a nitrogen molecule, and that's what's in the air, N2. That's how it goes together in the air. It's not a nitrogen atom by itself, but it's a molecule. Your key is on the front side, so anytime you want to represent any of these elements that we're combining, you'll need to look off the front to see how you combine them. Okay? So, number one, it says to draw a molecule of ammonia. Ammonia, what is this? On your terms, what is this? It can be multiple things. What is it? But what specifically, what term can we say that this is what? On your terms. What's that? It's a compound. What else is it? This represents what? That's one of our last terms. Maria? What's that? It could be a substance. It could be a chemical formula. And it could be a molecule, too. So it represents a lot of things. So what we're going to do is put nitrogen here. And then hydrogen on the front side has a little circle. So there's ammonia. Okay? That would be ammonia. It'll tell you a lot of times if something is in the center. Okay? Now ammonia and vinegar was put together, and at the bottom it has vinegar. So what's the chemical formula for vinegar? So carbons are black, so how many carbons do we have? 2. So we'll write C2. How many hydrogens do we have?
6, 5.
Those are the little circles.
4.
4. And then how many oxygens do we have? 2. There's another way to write this that would be better, but for now, these are chemical formulas you're writing out. These are particulate drawings you're drawing out. And so what I'd like you to do is, it shouldn't take you very long whatsoever, is to take and look at drawing and writing formulas for the rest of these for tomorrow. Okay? So why don't you do that? And also that lab for physical and chemical changes, let's have you head that in tomorrow as well and give you the opportunity. So, all right, so I'll come around if you got questions with that. But go ahead, and they'll get into some things that are elements and ionic substances too. And they'll have some reading that goes with it. So it'll say a textbook. If we get to the textbook, if you get down to number 4, we'll kind of do that together. So when you get down to number 4, we'll kind of do that one together as a class, because it's a little different.